me with all 5 of these questions. I'm going to draw 45, 45, 90. And I'm going to draw 8, 30, 60, 90. You could make it any 30, 60, 90. You could make it any 45, 45, 90. But we learned the other day the easiest option is the 1, 2 radical 3. And a 1, 1 radical. So the sine of 30 degrees, opposite over hypotenuse is? Cosine of 45?
1 over
which is?
Oh, well, 32.
Tangent of 45.
Fine.
Not going too fast. Secant of 60. Good. Opposite of cosine. So the cosine of 60 would be 1/2. So secant would be 2 over 1. And the sine of pi over 4. What is pi over 4?
It's 45.
45 degrees, right? So 4th of pi, a 4th of 180. So 45 degrees, sine of 45 degrees is 1 over radical 2 or radical 2. Any questions? This stuff right here is probably the biggest takeaway from trig that you have. In fact, your first week in AP Calculus, you will take a quiz of this. It's important. But for today, for this time, we're going to learn about angles on the coordinate plane. You kind of saw me draw a couple pictures, and I've led into this, but we need to actually define what it means for an angle to be on the coordinate plane. The initial side of the angle is the starting side where the angle starts to open, and the terminal side is the ending side. On a coordinate plane, the initial side will always be the positive x-axis. The initial side of an angle, if we put it on the coordinate plane, will always be the positive x-axis. And then if we go up from there, we'll get a positive angle. And if we go down from there, we'll get a negative angle. You've never thought of a negative angle before, so that's a little strange. But positive angles will be going up from the positive x-axis. Negative angles will be going down from the positive x-axis. When we put angles on the coordinate plane, positive angles go up from the positive x-axis, or counterclockwise. And negative angles go down on the positive x-axis or clockwise. Coterminal angles are angles that have measurements that are different than x by 360. What that means, like if you were watching a skateboarder and he did a 360 or he did a 720, would he land at the same spot? Those are coterminal angles. They land in the same spot, but they have different measurements. Looking at it just statically on the piece of paper, they would look like the same angle, but they have a different amount of rotation. So that's what coterminal angles is. So let's find one positive and one negative coterminal angle with the angles given here. So if I look at the angle 30 degrees, what would be another angle that would land in that same spot? 390. How'd you get that? Add 360, go around the circle. So, yeah, 390 is coterminal with 30 degrees. Those land in the same position on the coordinate plane, even though they have different measurements. What would a negative angle be that would be? Negative 330. How do you get that? Subtract 360, right? 30 Okay, so far. Okay, so 210. What is a positive coterminal angle to 210? 570. How'd you get 570? Add 360. And what's a negative coterminal angle to 210? Negative 150. Any questions? So 210 minus 360 and 210 plus 360. Find at least one. Find the least positive coterminal angle with a given angle. That's going to be important to us. After 360, you probably don't know where the angles go. Before 360, you could probably figure out where they go. After 360, you have to really think about it. Does that make sense? So being able to find what's called the least positive coterminal angle is important because we can study where it goes pretty easily once we get the least positive coterminal angle. So positive, we want it to be positive. Least, we're going to be talking about an angle between 0 and 360 to get the least positive coterminal. So if 910 is my angle, how would I go about finding the least positive coterminal? Subtract 360 until I get an angle between 0 and 360. How many times do you have to subtract 360 to get that? 190. That is what's called the least positive coterminal angle. That is something that will be important to us because we can work with angles that fall between 0 and 360 a lot easier than we can work with angles that are large. Same thing with negatives. At some point, negatives will fraying a little, and so being able to turn those into positive angles is nice. So how would I make negative 65 degrees the least positive coterminal? Add 360. What again? What about negative 850? 130, how do you do that? Add 360 so you get to a positive number, which would be 3 times, right? And what did you say you got? What? Negative 850 plus 360.
That's like a really big one.
You just have to, yeah, you could set up you could do an Excel file. You're not going to have fun in the millions in this class. 5 pi over 6. That's a bad question because that is the least positive, so I'm going to. Oh, God. I could find another positive one, but I'm gonna change those stages problems. If that really was the question, that is the answer. What was that? That was over 6. Was that over 6?
Yes.
They're better. Okay, so let's find the least positive coterminal angle of 18 pi over 6. I've got to switch my mode of my brain from degrees to radians. How far around the circle can I go for the least positive coterminal angle in radians? 2 pi, right? 2 pi is all the way around the circle. So I need it to be between 0 and 2 pi. Is 18 pi over 6 bigger than 2 pi? Yes, 0 and 2 pi. If I'm looking at over 6, what would the top number need to be? Less than 12, right? 12 or less. So I'm going to take 18 pi over 6 and start subtracting 2 pi. If I'm doing that by hand, I probably want to change 2 pi to be 12 pi over 6. So I'm going to subtract, and I'm going to write this one down. 12 pi over 6, which gives me 6 pi over 6, which is just pi. So pi is my least positive coterminal angle. I did the exact same thing I did with degrees. A little harder on the brain because radians are new to me. Any questions about that? Okay, the bottom one. What do I need to do? I don't need to subtract 2 pi this time. I need to add 2 pi. What would the denominator be if I were adding 2 pi to an 8 on the bottom? Good. 16 pi over 8 would be 2 pi. I need a common denominator. Everyone see why that's 2 pi? 2 pi. No. 16, 8. 16 divided by 8 is 2 pi. So I'm really just adding, let me write. I want to add 2 pi, right? But I need a common denominator. So I get negative 25 pi over 8 plus 16.
Just convert over to English.
No, we don't want to do that. I don't think so. Do you think it's easier? Oh, okay, yeah. Because if you convert to degrees, you'll have to multiply by 180 over pi. Okay, and so we got negative 9 pi, so is that enough?
No.
No. Or you could add 32 pi over 8. And so we're 7 pi over 8, which is a little less than pi, so we'd be in the second quadrant. So I subtracted 2 pi, and 18 minus 12 is 6. Second. I'll show how to work that. Every now and again, we'll have an answer to a question, and it will be all angles coterminal with 90 degrees. So we want to talk about how to write that in an equation. If I wanted to say all angles coterminal with 90 degrees, how could I get there? What would I need to do to get all angles coterminal? Plus or minus 360 n, I like it. And I'm actually just going to do plus 360 n, and I'm going to say that n, anyone recognize anything I just wrote up on the board? Okay. Z, does anyone remember what the set Z stands for? Like we knew R was real numbers.
A number of zeros.
Z is the integers, so just put that down for side note. Z stands for the set of integers. They use Z, not I, because I was kind of I bolded Z. And to do that by writing, if you see the textbook, you've seen it before with this. Have you seen that before?
No. Where? No.
The real numbers?
Rockets.
Okay. So anyways, you got introduced to a new symbol. And like an arrow, it's an E, and it stands for an element of. So this is saying N is a part of the integers. E. It is this weird looking E, kind of looks like an arrow. I thought it was an arrow until I was in college. But N is an element of the integers. I'm going to introduce you to some math notation as we go. Do I? Yeah.
C is integers. E is
An element of. That little weird looking E. It's not just any E. Don't like, right, E. But that one stands for an element of. So N is, it's saying N is a part of this set of integers. Yeah, you need to know like the little thing. You knew the R, didn't you?
No, we don't know. We never know.
Like you didn't write any answers that said all real numbers.
We want to address that we should all real numbers. So that means all real numbers.
Yeah, and this means all.
Why can't we just put X?
Because what's X? Maybe it's integers. Maybe it's one numbers. Maybe it's complex. Maybe it's
what's an all real number?
Let's talk about that really quick. Side note, has nothing to do with this. What are whole numbers? Start there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? Some books will include zeros, some won't, but that's whole numbers. What are integers?
Positive or negative.
Same thing, but positive or negative. What are rational numbers? Okay, fractions. Any number that can be put into a fraction is a rational number. Those are, they use a cube for rational numbers. And then after rational numbers, we've got real numbers. Real numbers encompass all of that, right? Real is rational, irrational.
So it's looking to write down.
Right. What's not real?
Imaginary.
Z is integers. You will need to know those words on the ACT. Those come up a lot. They don't write the notations, but they'll tell you something about integers or rational numbers. So you do need to know what's what.
What's the filter?
This one is the element of. So say N is an integer. Pretty much just what that is. N is an integer. Okay? How would I write this second one differently? Plus 2 pi. Good, you could do 12 pi over 6. 2 pi n. And again, n would be an integer. And you could say, if you forget that symbol, you could say n is an integer. That's exactly what we wrote. We just wrote it. One of the hardest things about going to college and reading a college math textbook is they will use this notation. And so it's kind of like you're reading.
You're literally reading.
Yeah. So I'm going to try to introduce you to some of this stuff when you get to college. You'll be able to read the text. My high school, like this teacher did that. It was very helpful. Okay. Reference angle or theta. That's the next thing we're going to talk about. Reference angle is the angle that the line makes with the positive x, or actually just with the x-axis. So write that down. Reference angle is the acute angle made by the line or the terminal side of the angle on the x-axis. Reference angles are going to be really important to you. So again, today's kind of a little bit of a boring day. It's notation, figuring out what this angle along the coordinate plane stuff is. Not a lot of hard math today, just learning some notation. Now, a lot of people want a formula to find a reference angle, and I will talk about that. My preference is that you use your brain and think about it, but I'll show you how you could create a formula for each quadrant. So a reference angle is an acute angle. Someone tell me what's an acute angle?
Less than 90 degrees.
Less than 90 degrees. The reason we're going to need acute angles is for when we go find the sine of 210 degrees or the the sine of 135 degrees. Really quick in your calculator, type in the sine of 210. Give me an answer. Well, how in the world did it come up with a value for sine if you have an angle that I can't even make a good triangle with, right? A good right triangle with. How did it do that? So that's where we're heading with this. But right now we're just going to talk about that. So, if I were talking about the angle 210, what quadrant is 210 in? Well, I have to put a little.
Third.
It's in the third quadrant. Does everyone agree? It's more than 180, but less than 270. It's in the third quadrant. So it would be like this angle. If I make an angle with the x-axis, this is 210, say 210, what would that little angle be? How would you find out? Subtract 180? And it would be 30? Type sine of 30 in your calculator. Now those are very similar answers. One's negative. We'll have to figure out how that happened. But they're very similar answers. So for the angle 210, 30 degrees is its reference angle. It's the angle it makes with the x-axis. That's what a reference angle is. In the first quadrant, they are their own reference angles. Right? Because from 0 to 90, those are all acute angles, so those are all their own reference angles. In the second quadrant, how would I find a reference angle in the second quadrant? (180 minus the angle. Because remember, I need to make it with the x-axis, not the y-axis. So wouldn't want to deal with 90, but you would subtract that angle from 180. Does that make sense? Get the little reference angle between that and the x-axis. Very, so 180 minus the angle. In the third quadrant, we figured that out. We subtract 180. And in the fourth quadrant, so I have an angle 330. But 360 minus that angle. So if you do want a formula, in quadrant 4, you do 360 minus the angle. In quadrant 3, what did we say you did? Okay. And then in quadrant 2, so if you really want the formula, there it is. I kind of hope you just think about it, because I would hate for you to have to memorize that. I think it would waste your brain space. It's a short exercise. So if I want the reference angle for 315 degrees, what's the first question I have to ask? What quadrant is it in? If that angle is bigger than 360, I'm probably going to have to find a coterminal angle first, and then go from there. So I know that 315, what quadrant is 315 in? 4. So what is a reference angle for 315? 45 degrees. Why is it 45 degrees? 360. It's 45 degrees from the x-axis. This angle there between that, remember it's to the x-axis. The biggest mistake people make with reference angles is trying to go to the y-axis. You always make the angle to the x-axis. Right, up or down, outside. Right? More reference angle examples. Go ahead and write this down. I do have a little worksheet. Hold on. More reference angles. It is your what is that? 4 book problems you got here? radian ones?
Yeah.
Negative one first. Let's do the negative one first. What do I need to do first? And what is 240 plus 360? 120. So that's co-terminal. Everyone know how I know that that's a quadrant 2, bigger than 90, less than 180. So how do I find a reference angle in quadrant 2? 180 minus 120, 60. Let's talk about radius. At first, you're really going to want to change it to degrees. Your brain's used to degrees. But I want you to practice leaving it as a radian. Your brain will get better at thinking radians. But the first thing I need to think about is, 1, is it between 0 and 2 pi? Is 5 pi or 6 between 0 and 2 pi? Yes. What quadrant is it in? Well, let me think about it. Is it all the way, is it a whole pi? No. Well, where's pi at? Pi's right here, right? And how many over 6 is pi? Pi is, how many pi's over 6? 6 pi over 6. This is 6 pi over 6. So where's 5 pi over 6? What? And so, what's the reference angle? We're at 1/6 pi, right? Pi over 6. 1 left. No. Your answer to this is pi over 6. That is my reference. It's pi over 6. That's my angle. And I know that pi is 6 pi over 6. Now, I just thought about it. Say you're stuck. How do you do it? Well, if you were in degrees, you would subtract from 180, right? So what's the equivalent of 180 in radians? So you would subtract from pi. So let's go back to this slide really quick and edit it. In quadrant 2, we would do 180 minus theta, but what if we're in radians? Pi minus theta. What if we're in radians? Theta minus pi. What about in radians? Okay, so we're going to use the same thought process. Try to keep it in radians. That's your challenge in it. Try not to change it. If you get completely stuck, could you change it? You can change it. Okay, so let's talk about 4 pi over 3. A negative radian? Sure. Now let's talk about negative 4 pi. Okay, so negative 4 pi over 3. We're going backwards, right? Okay, so I'm going to think about it in terms of a fraction. Right? Isn't it 1/3 more than 1? So we've got pi, which is right here. We're going backwards. So that's, I've gone backwards pi to that point. But I'm going to go 1/3 more. I think I just answered the question, didn't I? So this is 4 pi over 3. And that's pi, right? Okay. Any questions so far? Okay, so I know that this is in this quadrant. Now, could I first find a positive angle if I wanted to? If I did that, I'd just add 2 pi to this. It would be 2 pi over 3 would be this. So if I did it that way, 2 pi over 3 would be right there. So what is the difference between here? 1/3 pi. In fact, either way I work it, it's 1/3 pi. In degrees, could you do this without finding a positive angle first? Now you had to, didn't it? In radians, could you? It doesn't matter, you can do it either way, but because of the fraction thought process, you could probably think of it that way. But anyway, so that is pi over 3 is the reference angle. Again, if you get stuck, I will allow you to go to degrees and then back, but I would like you to try practicing thinking in radians to get our brains there eventually. I know it's weird right now. How many of you are starting to kind of get the hang of it, though? It's starting to... 3, so I get 2 pi over 3. That's the coterminal angle. That's not the reference angle. Then I'd go find what quadrant 2 pi over 3 is in. Would you agree that it's 1 pi less than 3 pi over 3? 1 pi over 3. So this is 3 pi over 3. This is 2 pi over 3. How far away? Over 3. So that's